Happy New Year, everyone, and welcome back to our Sky Tonight program. This is Seth again, curator of astronomy for the Loma Planetarium at MOAS. And in this edition of the program, we're covering the dates of January 3rd through January 9th, 2022. We're going to start things off by talking about the great Quadrantids meteor shower that peaks at the beginning of this week. We'll then discuss Earth's perihelion, its closest approach to the sun, and we'll talk about how that works. And we'll end by saying farewell to Venus in our evening sky and watch as Mercury climbs highest above the southwest just after sunset. So let's check it out. Every new year, we get to celebrate the annual Quadrantids meteor shower, and 2022 is no different. Now, I have to warn you, this meteor shower has a name that I struggle with quite a bit, so if I say it differently many times over, I do apologize. But again, this is called the Quadrantids meteor shower. And this meteor shower isn't as well known as some of the ones we had late last year, like the Perseids, or the Leonids, or especially the Geminids. Those are much more famous and are well known, but the Quadrantids should stand among those meteor showers as one of the greatest, and it really deserves it. So this year, the Quadrantids peak at about 2100 UTC on the 3rd, but it's really going to be best to view this in the early morning hours of the 4th, and that's when the radiant point for this meteor shower sits high enough above the northeastern horizon. So I would say from about 1 a.m. to dawn on the 4th will be your best viewing window. So here in Stellarium, I have our local time set to just after 2:30 in the morning, where you can see that radiant point sits high enough above the horizon, and that gives you increased chances of seeing more of the meteors from this particular shower. And the name Quadrantids is quite interesting. It is one of the only meteor showers named after a now defunct constellation, a constellation known as Quadrans Muralis, which in Latin means the mural quadrant, a wall-mounted angle measuring tool that were used by astronomers. And the constellation was created in the late 1700s and persisted all the way into the 1920s until the International Astronomical Union omitted Quadrans Muralis when it decided upon the 88 constellations that we use today. So this radiant point sits in that area where those stars would have created Quadrans Muralis, hence the name the Quadrantids. And if you do want to find it in the northeast in the early morning at this time of the year, it's kind of sandwiched in between some fairly known star patterns. If we turn on some of the constellation lines here, we can find a very familiar shape above the radiant point, and that is the Big Dipper, of course part of Ursa Major, the Great Bear. So the handle or the tail of the bear sits just above it. And to the right is the fairly well-known spring constellation of Boötes the Herdsman with the really bright star Arcturus. And to the left, the meandering constellation of Draco the Dragon. We can turn on the pictures just to show you what constellations reside in this area. So that old wall-mounted quadrant constellation used to kind of fit in this part of the sky. So going back to this particular meteor shower that occurs at the beginning of January of each year, this has a relatively short window. It lasts from about December 28th to January 12th, and it's spurred by an asteroid known as 2003 EH1. This is an interesting asteroid because it's one of those rock comet-like objects. It may have been a comet long ago, and as it passed by the sun over and over again, the sun's radiation may have evaporated all of its icy material away, leaving behind the denser rocky material. This is similar to the object that creates the Geminids that we mentioned last December, called 3200 Phaethon. So these rock comets or active asteroids leave behind a trail just like comets do, and we are moving through the debris trail of 2003 EH1 at this time of the year. And what's great is that this meteor shower can have very high meteor rates, up to 120 per hour. So that's pretty good, and higher than the majority of meteor showers that you can see all throughout the year. And what's also helpful is that the moon is near a new moon phase that occurred on the 2nd of this week. So we don't have a moon that can obscure your view of a potential Quadrantid meteor that could be streaking across the sky. So with that, and hopefully some very clear sky conditions, you may see one of the faint streaks of light coming from a Quadrantid meteor overhead. And again, you got to get out there in the early morning of the 4th, sometime between 1 in the morning until dawn. And of course, the later you stay up, the higher the radiant point for this meteor shower gets, which increases your chances of seeing even more of the meteors from this particular shower. So this is a nice potential celestial event to enter into 2022. Hopefully the Quadrantids put on a really nice show as we watch the particles from an ancient asteroid rain down through our atmosphere. So this year on January 4th, there is a celestial event occurring that you're not going to notice visually in the sky, but it's really cool to know, and that is we're at what's called Earth Perihelion, and that is our closest approach to the sun that occurs in January. And the word perihelion is ancient Greek. It actually means around the sun or close to the sun, depending on the translation. Para means around, and helios is Greek for the sun. It's where you get the word heliophysics or even the word helium. But anyway, at this time of year, we are closest to the sun at about 91.4 million miles. And what's interesting for us here in the Northern Hemisphere is that is when we're in the wintertime. So it reminds you that even though we are the closest to the sun at this time of year, that is not what influences our seasons. And if you recall from a couple episodes ago, we talked about that the Earth's tilt is what causes seasons. And in the winter, especially on the December solstice here in the Northern Hemisphere, we are tilted furthest away from the sun. So the sun's angle is hitting us less drastically, and we're receiving less energy from the sun at this time of the year. And conversely, in our summer, in early July, is when we have what's called aphelion. That is our farthest distance from the sun, where we're about 94.5 million miles away. So the difference between our closest approach for perihelion and farthest distance from the sun at aphelion is about 3.1 million miles. And that may seem like a lot, but in the grand size of our solar system, that is not much. And if you looked at the orbit of Earth from above, our orbit is almost nearly circular. That difference between closest and farthest approach is only about a 3.3% difference. So it's not enough to cause really big temperature changes here on our planet. And when you compare the orbits of other planets, all of these orbits are all elliptical, but again, from the top, they mostly look circular. And the more circular or oval-shaped an orbit is called its eccentricity. In mathematics, if you have an eccentricity of 0, you are perfectly circular. If you have an eccentricity of 1, you are parabolic, which is basically an infinitely stretched elliptical orbit. That's an escape orbit, essentially. So planets in the solar system are between 0 and 1, but all of them are practically close to 0, with the most extreme examples between most elliptical and most circular are the two closest planets to our sun, between Mercury and Venus. Mercury, of course, is the closest planet to the sun, but also has the most elliptical orbit in the solar system, with a 34% difference between perihelion and aphelion. But with Venus as the second planet from the sun, Venus has the most circular orbit of any planet in the solar system, with only a 1.3% difference between perihelion and aphelion. And just remember, Earth has a 3.3% difference between those two extremes. So it's interesting to compare those eccentricities and how much that may influence a planet. But at least for us here on Earth, we can celebrate our perihelion, our closest approach to the sun, on January 4th at about 91.4 million miles away from the sun. So we'll say happy perihelion on that day. Now, as we head to the west, very early in the week, just after sunset, you may still have a brief chance of seeing the planet Venus before it dives into the full glare of the sun. And you can see this is on January 3rd here in the evening. There is Venus just peeking above the west and southwestern horizon right there. And we've had a great time with Venus, especially through the fall and into the winter time. We got to see Venus at the highest position above the horizon, at its brightest that it can get. And we watched as Venus went through some really interesting phase changes, especially as we were nearing this time of the year when Venus was at a very thin crescent shape, which is always so cool to see through a telescope. So now we can finally say farewell to this planet, at least in our evening sky, as it descends closer to the sun, at least from our perspective. And as we continue through the week here, we'll go to the 4th and the 5th, and we'll make it just a little bit later, because what's actually happening is another planet has been replacing it in our sky, at least in this area. And that is the nearest planet to our sun, the one we just mentioned earlier with Mercury, that has that very elliptical or eccentric orbit. So if we go to about the 6th or the 7th here in the evening, we're going to find just above the southwestern horizon is that planet Mercury right there. So by then you just saw how Venus dove into the sun's glare, and Mercury's kind of in the similar location where Venus was not too long ago. And on about the 6th or 7th of this week, this is when Mercury hits what's called greatest elongation east. So that means it's in its most eastern position in our sky at this time, and about the highest it gets in the evening, until it also plunges into the glare of the sun. Mercury moves even more quickly than Venus does, so it changes quite drastically from night to night, but this will give you the best chance of seeing this very small planet in our sky. And what you may notice is just above it, the planet Saturn is there, so that's nice. And then above that, we still have a great view of Jupiter. And on this evening, especially on the 6th, you'll have a nice crescent moon as well. So you have a lot of solar system objects in this area. The moon, Jupiter, Saturn, and Mercury there, and then Venus again in the sun's glare. And by Sunday the 9th is when Venus is at what's called inferior conjunction. If we turn off the ground and even the atmosphere here, we can actually see that happen. So there's Venus here, and we'll go to the 9th here. So we'll go to the 7th, 8th, and 9th. And there is actually when Venus is closest to the sun, at least from our vantage point. So when Venus is most in between us and the sun in our orbital configuration at the moment. And after this is when Venus continues to move in that direction, eventually entering into our morning sky as we get into late January and then into February. So Venus doesn't stay hidden for too long in the glare of the sun. But of course we can't see all this since we have the ground and even the atmosphere turned off, but we'll go back to about the 6th and 7th here when we find Mercury in its highest position in our sky. And one little addition as well is that Comet Leonard may still be possible to see at this time in this area, or roughly in this area, a little bit more to the south. And actually, if we go back even a few more days before this, to the 3rd, is when Comet Leonard is reaching its perihelion. So only one day off Earth's perihelion, since Earth's perihelion is on the 4th, this is just the day before on the 3rd, when this comet reaches its closest approach to the sun, its very last time, because it's on a parabolic orbit. And it's nice when previous concepts apply to others that we talk about. So this parabolic orbit means that it's on an escape trajectory, and it's the last time it crossed paths with us and the sun before it moves away from the sun and into interstellar space. And it'll be on its own from there on out. So at this point, this is when this comet could get even brighter since it's at its own perihelion. But we shall see, we just don't know because of the unpredictability of comets. So it's great to know that in this area where we're still finding Mercury and Saturn and Jupiter, Comet Leonard is somewhere in that vicinity. If you're looking very low in the southwestern horizon, maybe it'll brighten just a little bit more to give us a better chance of seeing it, especially if you have a telescope or binoculars and you look towards this area at the right time. Well, that's it for our first full episode of 2022. Thank you very much for tuning in, and we hope to see you sometime this year at the Museum of Arts and Sciences and definitely our Lohmann Planetarium. We're running shows every day, and we've got a lot of great shows on our lineup, so please check our schedule for any more information about those programs. So I hope to see you back here again. Take care, and of course, happy stargazing.